Hi everyone. So let's get started. Today is very exciting for me because I'm going to start something very much. We will be starting with first linear and covering linear so much depth that you will never ever you will get to understand what is a vector, what is a matrix, how all of this is making sense. Since it is marathon, so I will be little fast, but doesn't mean that I will be covering everything. I will be going from scratch and the depth that is for gate. So one disclaimer is there that I will not be covering which is more than gate. I will be covering everything required for gate and precisely for gate. So we will be covering the way that given this 4 to 5 hours, we can cover maximum and be able to score whatever question is given in the exam. We should be able to get exam the full marks. Hello, there is some voice. Let me just voice is. I will keep this mic little closer. Maybe that will help me. Let me know if things are good now. Maybe now it is better. Can you quickly confirm? Okay. So let me know if it is better. I hope this should be better now, right? Okay. So let's just get started. So now I hope everything is clear. My audio and video, everything is fine, right? Cool. So I was saying that in this marathon, we will be covering everything that is required for gate. And there is one disclaimer, which is that I will not be going anything beyond gate, but we will keep ourselves so precise that in this 4 hours, in this 4 to 5 hours of duration, whatever for whatever time this marathon is going on, in this meantime, we should be utilizing it so precisely that there should not be anything that is like that I will be covering that is not required for gate, or at the same time I will not be missing anything which is required for gate. So we will keep ourselves very much precise for this 4 hours next. Okay, so let's just get started, and we will be starting with our first topic in engineering mathematics, which is linear algebra, right? Now, this linear algebra is very close to my heart, but it doesn't mean that I will be I will be going beyond gate or something. So whatever I'm going to cover, I will just give you after the theory. I will be giving you the gate PYQ so that you get to know the relevance of everything which I'm teaching. Okay. Now, let me first see if there is any doubt. Now, Apan is saying, sir, can I watch this first time? I never did EM. Yes, you can definitely watch. Okay. Great. Let's just get started. Now, linear algebra for gate, it is just for 1 mark or 2 mark. Generally, it is for 2 mark. 1 mark is in the rare case. In the rare case, it is for 1 mark. But yeah, generally it is for 2 marks only. So I can say very rarely they will be asking just 1 mark question, but it is for 2 mark to 3 mark. So in the gate, I can say it is two to 3 marks of the subject. Now, not just gate. Let me just tell you that apart from gate, where do you need this linear algebra? Like, one thing is that they will be asking in the gate, that is for sure. Another thing is that they will be asking it in the interviews. So let me just take 5 to 10 minutes, because it is worth to spend 5 10 minutes to give you the knowledge of the opportunities that you will be getting after gate. So gate is not just one exam. After that, you will be saying that you will be going to IIT, or if you ruin the gate, then you will be not going to IIT, like that, right? So if you get top rank in the gate, then if you get top rank, then you may be getting direct admission to many of the IITs. So direct admission to many IITs. Direct admission to many IITs. If you get top rank. But if you do not get top rank, then they will be calling you for the interviews. So let's suppose your rank is around maybe let me just call it 1200, because there are many students with the 1200 rank also. They also get the opportunities in the IIT Madras or IIT Kanpur or even IISc sometimes. So if your rank is around 1200, then they will ask you for the interview. They will call you. They call for MTech interview. Now, in this 1200 rank, suppose your rank, it is not a rank of a matrix, it is a gate rank, okay? It is not a rank of a matrix, so it is your gate rank that I'm talking about. So your gate rank, it let's suppose is around 1200 AIR. Then they will call you for the MTech research interview. Now, let me just take 2 minutes to clarify what is this MTech research, because most of the student has just wrong assumptions about it. So they will call you for interview for MTech research. Now, some of the students think that this MTech research is no good. I mean, after all, they are calling it for 1200 rank. Then why should it be good? So it's not the case. Basically, this MTech research and MTech both are the equivalent program. This MTech, which is of 2 years of program, is as good as MTech research. Both are the equivalent program in terms of anything that you can think of. In terms of placement, yes, both are equivalent, which means that no company differentiate between the MTech and MTech research. In terms of job, they are same. In terms of PhD or the future academic opportunities, future academic opportunities, everything is same. It is just that MTech research is going to take you 2.5 years, which is just 6 months extra, which is also good actually. 2.5 years to sometimes 3 years also. So MTech research is just studying something in more depth. That's all, right? And MTech is something which is basically fixed hours, fixed duration. It is for 2 hours, 2 years. Now, why there is an assumption that MTech research is no good? Like, I mean, there might not be assumption, but I have seen few students those think that MTech research is no good. So let me tell you that why they think it. So they think that MTech research is basically for the people. Like, actually, to be honest, I also used to think back then, after after 2015 or maybe before 5 to 6 years, I also used to think this MTech research is no good. Like, I got 1100 rank in my first attempt, and I have not I have not filled any form for MTech research, because I used to think that this is not a good program. But then later I got to know that this is very very good program. So here in the MTech research, they just ask you to stay for 2.5 years, and since they are asking you to stay more, then it is automatically, just see here, this 0.5 years or 6 months that they are asking you to stay more, or maybe 1 year in some cases, then it is automatically mean that you know many more things than MTech people. See, you are going to spend more time in those premier institutes, right? Like IITs and IISc. If you are going to spend more time in those top notch institutes, then automatically you are going to learn more. Then, see, the companies do not differentiate between MTech and MTech research, obviously. So, if there is any company, they do not differentiate that MTech and MTech research, they do not differentiate. But this MTech research people in general, see, it depends on person to person, but they in general have more knowledge, have more domain knowledge. I mean, more subject knowledge, basically. If you are not comfortable with this word domain, in subject knowledge, since they are having more subject knowledge, then automatically they will be preferred. I mean, company do not differentiate, but they automatically outperform. See, there is a person, let's suppose, who is a MTech person. There is a person who is, let's suppose, MTech research person. Then, since his knowledge is most probably, I'm not saying in all the cases, but because MTech research guy could also be very excellent. I'm not comparing it, I mean, in very general way, but yeah, most of the time it happens. Since they spend more time, then automatically they tend to know more. Like, there is no one who can stop them. So basically, automatically they know more. Okay, they know more. It's just like that, they know more. Like, company do not differentiate, but they have the more knowledge. That's why they automatically outperform. And more generally, I can say that in most of the IITs or ISC, they tend to get better placement. So hence, it is very very easy lemma, right? So I can say it is very easy lemma. If this person is knowing more, right? This is a MTech research person, and this is a MTech person. If this is having more knowledge, then it directly implies that better placement, right? Obviously, better placements. So it's like that. This person is having more knowledge. That's why they generally tend to get better placement. It's not like the companies are differentiating. It is just like they automatically outperform. This is what I'm saying. I hope you understand and you do not take my words. In other way. Okay, great. So let me know if there is any doubt. So I hope you are convinced that MTech Research is a very good program. That's why that's what I wanted to just convey. And if you study this linear algebra, then this is just one program that will help you. This is just one subject. This 4 to 5 hours that we are going to spend, this 5 hours that we are going to spend, they will help you to get into IIT. Not just IIT, okay, top IIT I can say. These 5 hours can help you to get into top IITs, in fact to IISc. Let me just tell you few examples of the student those have studied our this linear algebra and they have went to IITs and IISc, top IITs and IISc. Before that, just let me tell you that what they ask in MTech Research in the interviews. Okay, so generally, so this is the pattern. If you can see my screen, that let me just adjust my video maybe. Yeah. So if you can see my screen here in the MTech Research, generally they either ask you from, they will ask you for the choice like in which domain you are comfortable. So this is the domain 1, this is the domain 2, and this is the domain 3. Now, in this domain 1, they have algo, graph theory, TOC, maybe sometimes discrete mathematics also. Sometimes they focus more on set theory, sometimes they focus more on graph theory. That's why I've written graph theory separately. And there are many other subjects that comes under theory, right? So they may ask you for the programming, maybe data structures and all. So these are the subjects that come under theory. So if you are going to appear for MTech Research program, then they will ask you for these subjects. In their theory they will ask you for the choice. Once you pick the theory, they will ask you from these subjects. Once you pick the system, they will ask you OS, COA, DBMS, maybe compiler, these subjects. Once you pick the third domain, which is machine learning, okay, which is intelligence domain, that they call it machine learning. The name is too much exaggeration. That intelligence, it seems like not, this is not the only intelligent. The other domains are also intelligent domains, but it is just a name that they call it intelligence domain. So here they just ask you linear algebra probability. Now, if you see in terms of MTech Research interviews, then this linear algebra itself, they mostly focus on the linear algebra. So if you see this linear algebra, this alone subject is as good as studying 5 subjects at mastering in 5 subjects, and mastering this alone linear algebra is same. As far as the interviews are concerned. So that's why I'm saying that there are many students, they have preferred to go for the linear algebra instead of prefer to go for these domains, and they finally get into the interviews, because cracking the interviews in the LA is comparatively easy if you actually know the concept. If you do not know the concept, then obviously it will be difficult. But if you have actually studied it, then these 5 to 6 hours can get you into IISc and IIT. That is my promise. Okay, and I can show you the examples. Those are the students that have just studied our linear algebra and they are now studying in the IITs and IISc. You might have seen many examples in our website, but let me quickly go through the other examples that I have currently. Okay. Uh, Now let me just show you the examples. See, this is the first student. There are many students. I'm just going to show you a few of the examples. Sakshi Joshi, she has went into IIT Madras, and her gate rank was, I do not remember, but actually I do not remember, so I cannot say for sure. But I think it was greater than 1,000. Her gate rank was greater than 1,000, if I remember correctly. It was not in under 500, that I am sure of, but I do not know exact rank. Maybe 800, 900, or I think 1,200, if I remember correctly. To be precise, I think it was 1,200 or 1,500 even. Now I can remember it, but yeah, I'm almost sure it is greater than 1,000. So now, even after getting greater than 1,000 rank, she went into IIT Madras just because of linear algebra. And after getting into IIT Madras, she wrote an feedback for us that for the first time I actually understood what exactly linear algebra is. Whenever I study linear algebra, it just seems a lot of processes and formulas. But after attending Go classes lectures, all the formulas and the process now seems logical, and instead of memorizing everything, I am able to understand and apply the concept. It was very, very satisfying. Sachin sir explained the system of linear equation with so much clarity that I am able to decide and answer the gate questions with the ease. Thank you, Go Classes, for providing such an awesome course. So it is just one feedback. Let me quickly go through the few feedbacks and let me tell you that how the students have felt in the past and how they have made it to ISC or IITs, and what is the, like whatever I'm saying, does it any backup with any proof? So that's why I'm showing you the feedbacks here. So Milan is in ISC, and he said like he has enjoyed ISC this course too much. It helped to help so much in interviews after gate. See, the people are focusing in the interviews after gate. They just get into this ISC or IITs or top colleges just because of those interviews. Just see that what is the power of the subject. Just before going to ISC, I also did not know the linear algebra and probability has so much power that they can get into the ISC and IITs. But after going there and after interacting with the students, that how they are getting into ISC even after not securing top 100 rank, then they told then I get to know actually that there is a program which is MTech research, which is as good as MTech program. And let me tell you, at my time in 2017, one of my very close friend, Deval, he has got AIR1 in 2017. And you might be surprised, but it is not surprise for me because I know that both programs are equal. You might be surprised that he has chosen to go for MTech research. Okay, he has chosen to go for MTech research, even though he was obviously offered for the MTech. I mean, he was offered for the 2 years program. Still, he wanted to go for 2.5 years of program just because he wanted to stay more time in ISC, because he wanted to learn more. And there are many people, he is not just one example, there are many people, even after under 100 rank, those people prefer to go for MTech research. Okay, they will, even after getting AIR1, all India rank 1. Okay, just think about it. All India rank 1. He has chosen MTech research over the MTech. So this is not like the MTech research is a bad program or something. That's what I want to convey here. Actually, I want to interact with all of you regarding this MTech research and MTech, but I will do it after the gate. I will tell you that how to prepare for it, what is the opportunity that you have, and I will tell you many other things. Okay. So Dark Shadow is asking, sir, when will the probability statics revision? It will be tomorrow. So similarly, this Hers is saying that he has went to ISC and he is saying that the course is very good like that, right? And this person Dhaya is saying that the I really enjoyed the online course of engineering mathematics. I thought that it will be well planned. I thought it was well planned and laid out, easy for me to follow. The explanation was just enough. I could finish everything with enough time. I learned about the topics and did not feel overloaded and rushed. Overall, I really like the classes because all the lectures and examples are straightforward. The course was everything. Course was everything you said it would be. Fun, but lot of work. Yeah, obviously it will be a lot of work. I mean, you need to pay attention. Definitely, it's you cannot you cannot watch just like a movie. I also like the examples and the way of narration. I never expected to learn so much from the online classes. I now see the engineering mathematics in a whole new way. That's my, again, this may promise that after this lecture you will be seeing this linear algebra and probability within the whole new way. I now see the engineering mathematics in whole new way. I now I could have done. I know I could have done better, but at the end, I learned the online classes could be so much work or more than the regular classes. However, I still enjoyed it very much, and so on. Right? So he's saying that he is now seeing the engineering mathematics in completely new way. Anyway, Sridhar has gone to ISC and he has achieved all India rank 25, and this is what he is saying for the classes. Similarly, there are many other people like this person has also said like he has got AIR 809 with the confidence of cracking any further AI specialized exams and interviews. See, now he is basically confident in even the cracking AI specialized exams and interview, because the way we have covered all the things in the course is actually very much structured, like how it is related to machine learning, how these concepts are really helpful in the gate questions, and everything we have covered in very formulatic and strategic way. So that's why the people are liking it. So last but not least, Abhishek has went to ISC in the CDS department, and they take the interview. They take the interview in linear algebra. Okay, at the CDS department, if you go. And he's saying, I would like to thank Sachin Mittal sir and Gator for their precious guidance for helping in the cracking interviews of ISC and IIT Delhi. So he has cracked interviews of ISC and IIT Delhi, which is obviously a huge thing. So now you can see that how much people are liking the course and how this alone subject is helping them to cracking the interviews. Okay, so these are just one example, like a few examples that I'm giving to you, but there are many others, and obviously I also do not have track of these examples. I mean these feedbacks, because we are too I mean, our focus is not to collect the feedback, like, to be very honest. So this is just what I remember. That's why I'm just pasting the screenshots. And generally, we get many messages. And this is one, I think, okay, this is one last message that I recently got from Aditya. He has went to IIT Kanpur MS winter admissions just because of our lean algebra and probability course. I watched your lean algebra and probability course, and almost all the interview questions were asked from the what you taught. I want to say big thank you to you and Go Classes for providing these lectures. So this is just a potential of one subject, just 5 hours potential that you can get into IITs or IISc even after you get the rank around 1200. So my request to you is that just attend this marathon in so much attention that you should not be lazy in this 5 hours. I will be putting my whole of energy here. You just put your whole of attention, and together we will make some sense. Okay, so let's get started. Linear algebra, why? Obviously, it is in GATE syllabus. That's why we are studying, right? Now, what do you think? Why? What is the other reason we are studying? So the other reason is that obviously the interviews, and if you look beyond the interviews, if you look beyond the GATE syllabus or everything, obviously we will not be covering. I'm just telling you that it is also very helpful in understanding the data interpretation. So for example, let me just tell you one example here. Let's suppose you have any data, whether it is text data, whether it is video data, whether it is audio data, whether it is number data, whatever it is, okay, that can be represented in a matrix. So any data that you have, any data can be represented in the matrix form. What do I mean by that? So you have any data, you can represent that data in a matrix. For example, if I just ask you how you will be representing I am Sachin, this sentence is one text data. Let's suppose this is one text file that I have, a.txt. This is one text file that I have, which is a.txt. How you are going to represent this as a matrix? Can you tell me? Yes, the answer is very much known for the machine learning practitioners. The answer is that every word in the machine learning basically get represented using a vector. Okay, so I will be representing I using a vector, M using a vector, and Sachin using a vector. Using these three vectors, I will be writing these three vectors here, and I will be saying that I can represent I am Sachin in a metric format. So anything, okay, whether it is text data, whether it is video data, whether it is audio data, whether it is image, whether it is a time series data, whether it is a number data, whatever it is, you can represent that in the matrix format. I'm just giving you one example that how you can represent the text data. Similarly, you can definitely represent the audio data, or there are many ways to represent the audio data, to come up with the vectors, but you can definitely represent any data in the vector, in the matrix. And once you have the data in the matrix, then everything that you do on this matrix is basically linear algebra. I mean, the combination of linear algebra plus probability, and any application which is the machine learning application you do on top of this matrix is basically backed up with the linear algebra and probability concepts. So you will be applying the ML, no doubt, but those concepts of ML will definitely be backed up with the linear algebra and probability concepts. So that's the power of linear algebra and probability. Whatever you are seeing, I mean, you must be seeing ChatGPT now, right? So ChatGPT is also a machine learning model or deep learning model, and that must be using linear algebra and probability, because without linear algebra and probability, machine learning cannot even exist. So let me just quickly walk you through few of the basic terms. Then we will solving the GATE PYQs. Then you will get to know that how you can easily solve the GATE PYQs if you have the depth of understanding of these subjects. So what is a scalar? Just let me just get started with the scalar. What is a scalar? Scalar is any number. Let's suppose 3 if I write, then this is a scalar. Let's suppose 2 I write, that's a scalar. Let's suppose -5 I write, that's a scalar. 0 is a scalar. Scalar is any number, right? Now similarly, if I ask you what is a vector, then you will say a vector is looking like this. Something like this is a vector. This is a vector, right? This is a vector. Okay. Does this suffice to me? No. Let me just give you some examples. Suppose you have some coordinate system which is x and y. This is a coordinate system you have. Now in this coordinate system, let me say that there is a coordinate which is 2, 3, right? Now there are different ways to represent this 2, 3. One is that you represent using just like this, which is also very fine, which we used to do during our I can say during our high school classes. Maybe we used to represent like this, and then we went to college. Then we used to say that okay, let's just represent this vector using something like this, right? So both are fine. I mean, either you represent a vector just like a coordinate system, just like this, or maybe you represent a vector just like an arrow, right? Both are perfectly fine. So you can represent a vector just like a coordinate, or you can represent a vector just like an arrow. Both are perfectly fine. Let me know if that makes sense to all of you. Okay. So Varun is asking how many marathons will be there for the EM. I am planning 3 marathons. Okay. So maybe let me just quickly tell you that number of marathons for EM. My plan is to have three marathons. One is for LA1. I mean, I will be covering most of the part, but there is just a few parts that I might not be able to cover, that I will be covering here in the second marathon, which is LA2, and then I will be covering probability here. Most probably probability will be covered in this marathon, but by chance if the probability is left, then probability 2. And if you people want, then we can cover the calculus also in the third marathon. Otherwise, we can just cover the remaining portion of the probability. Calculus lectures are already available on our YouTube channel. That's why I'm just saying that this will be optional based on that what you people want. Cool. So I hope the vector definition is clear to everyone. So this is how the vector look like. Now let me tell you how does a vector look like in R2. Okay, which means let's suppose you have some vector. Then if I just say that this vector is in R2, it means it has the two dimension, two or three, one or two, which means either you can represent this vector just like this, which means 1 comma 2. Maybe you can say this is in the vector format 1 2, right? So these are the two notation that you use. You use this notation does not matter to us, but for our purpose, for our linear algebra, this looks pretty nice. You might not be agreeing with me that white is looking nice. You may say that this is looking nice, but I will convince you very soon that this is the only vector that makes sense. I mean, that looks nice to us, which means it is most convenient to write a vector in the column format, not in the row format. I mean, you can write it, but generally we write it in the column format. Okay. So this is the vector that we call is in two dimension. Two dimension means R2. Now, similarly, if I ask you that there is some vector, maybe 1, 2, 3 or something like this 1, 2, 3, this vector is in which dimension? Then can anyone tell me this is in Rn? So what should I write here? R power 3, R power 4, R power 2, R power like R power 1. What should I write here? Can anyone quickly tell me? Let me know. So obviously it will be R2. Yes, right. It will be R2. Sorry, R3. It will be R3. Now, let me ask you one more question, which might be tricky, but it's a very easy question. Let's suppose if I just ask you 0, 1, 0, or maybe 0. Okay, let me just give you 1, 2, 0. This vector is in which dimension? This vector is in R2 or R3? Because remember, one of the coordinate is 0. This vector is in which dimension? This is also an R3, right? It does not matter if what is the value of these coordinates. Could be 0, could not be 0, but it is having the three dimensions. I mean, three coordinates. It is in R3. Now you know what is a vector in R2, R3. Similarly, you can easily tell me what is a vector in Rn. Rn means if it is having n coordinates, right? 1, 2, 3, like that. If it is having n coordinates, let's suppose the last one is xn. Then I say, okay, I mean, this is x1, this is x2, this is x3, and last one is, let's suppose, xn. Then I say this vector is in Rn. Cool. Now you know what is a vector. I mean, how does a vector representation look like? Now let me just go through a very quick definition, which is scalar times vector. If you do a vector and scalar multiplication, then how does it look like? Let's suppose there is a vector which is 2, 3. If you multiply this vector by any scalar, maybe 2, okay, or maybe 5 or anything. Let's suppose you multiply that by 2, then you know that this will look like 4, 6, right? 4, 6. So that's how you can multiply a scalar and a vector. Very easy multiplication. Now let me just tell you how does a two vector addition look like. Okay, which means if you want to add two vectors, maybe 1, 2, 3, and another vector could be 2, 0, 9, then how you will add it? You will be adding it dimension wise, which means 1 plus 2 is 3 and 2 plus 0 is 2, 9 plus 3 is 12. So that's how very easily you can add it. So that's how the vector addition look like, right? Now you might be wondering that why I'm telling you all of this elementary stuff, because you might think that it is elementary, but I mean, for you it might be elementary, but for some of the people who are not from the computer science or mathematics background, for those this elementary is also required. So that's why I'm going step by step, but we will go to the depth that is sufficient enough for GATE or sufficient enough for any interview that you are looking for after the GATE. Obviously not for the interviews, specialized interviews like machine learning interviews. For that you have to obviously study the machine learning, but for particularly like IITs or ISC or ISC interview, you will definitely be getting all the things that are required there. So if you want to add, let's suppose these two vectors, you can definitely add. Now this 7 comma 7 will look something like this, right? So here this is, let's suppose 4, so 7 comma 7 will be like will be here, let's suppose. So I think I have the diagram. Okay, I do not have the diagram, but 7 comma 7 will look something like this. So this will be the 7 comma 7, let's suppose, right? You can also draw the 7 comma 7. So there is a rule, I mean, using which you can also find out the dimension of direction of 7 comma 7, but it's not required, right? I mean, you might be knowing the triangle rule. And cool, let's move further. Now let's go to the first interesting topic, which is linear combination of the vectors. What do I mean by that? Suppose you have two vectors and you want to have the linear combination of the vectors. For example, let's suppose you have these two vectors and these two vectors linear combination you want to find out. Linear combination means you want to multiply this vector by some scalar, maybe 3. You want to multiply this vector by some scalar, maybe 2. And then finally you want to know what is the number. I think what is the vector that you are getting. So I think you can do it because this is the scalar multiplication, this is another scalar multiplication, and finally you will be getting a vector addition. So that's how you will be doing it. That is called linear combination of these two vectors. Now see here, this is one vector, this is another vector. Now these coefficients could be anything. For the linear combination, I will say any coefficients will create one linear combination of these vectors, right? So you can definitely find out the linear combination of the vectors like this. Okay. Now slowly the things will become more and more interesting. Now you can have any scalar, as I said here, like you can have -1, not 5, 10 or anything, and you can definitely find out the number that I have completely trust on you guys. So if I just ask you to find out the linear combination of these three vectors, then can you do it? I think everyone can do it. But I will flip this question in a opposite way in just a while, and the whole story will change. So for now, let's keep it very simple. If you have given a vector, you are given some scalar, and they are asking you to find out the linear combination of some vector for these three vectors. So probably if you do it, then you will be definitely getting. Sorry, I mean, let's suppose this is 1 to 10 that you are getting here. Okay, let's suppose this is 1 to 10 that you are getting here. So that's how you can definitely find out the linear combination of the vectors. Okay, not this is not 1 to 10. This is, I think, okay, I can even do it. 4. Okay, this is 1 to 10 only. Cool. This is 1 to 10. 3 plus 4 7 plus 2 plus 2 5, this 9. Anyway, 9. This is -6 -6 -8. Okay, so this is 1 to 9. Cool. So this is 1 to 9, not 1 to 10. Anyway, you can definitely find it out. Now let's suppose that if I give you this combination, which means I give you everything, I give you this scalars, I give you the vectors, and I ask you for the linear combination, then you can definitely do it, right? There should not be any problem in this. Now if I just flip this question, very soon we will be flipping this question. Okay, so suppose this is 9 or 10, does not matter. So very soon we will be flipping this question. I will be not be giving you the coefficient, and I will be giving you everything. See, earlier I have not given you this thing, which is very easy to compute, right? Very easy to compute. You can definitely find out this linear combination. But now, very soon, we will be flipping the question, and whole of the linear algebra is revolving around it. This is called Ax equal to b. How it is called Ax equal to b? I will relate it to Ax equal to b. But yes, this is called Ax equal to b, and they are asking for the x. They are asking for the s. Similarly, I am asking for these coefficients. So all of this is basically the same story. We will relate it, right? Now let's just move further, and very soon I will come to this again. Remember this, okay? Remember this, that I'm asking for the linear combination. It is just I mean, it is just class 5 thing, or maybe class 10 thing. Then after after some time, very soon I will be jumping to this, which is basically class maybe BTech thing or engineering thing, you can say, right? I mean, gate thing. So basically I'm currently here, but I will be jumping to this, and before that I need to cover some of the basics, so that's why I'm not jumping directly. So let's cover some of the basics. Now you know what is a vector in R2, what is a vector in R3, what is a vector in Rn. What is a vector means, how does it look like. It looks like this. Here it looks like this, right? Here it looks like the n dimensions. So that's how the vectors look like, right? N dimensions. Cool. Now this is the dimension of this vector is 2. Similarly, the dimension of this vector is what? 3, right? You have already answered this, that this is in R3. Cool. Now what is the dimension of this vector? I think this also you already answered, which is R3. Now let's get started. Before that, I just want to phrase one sentence from very popular book, which is saying that this gentle introduction to scalars and vectors seems very simple, But you may be surprised to learn that nearly all of the linear algebra, all of that, whatever we have just studied, okay, just in 10 minutes, all of this linear algebra is built from those scalars and vectors. Literally all of the linear algebra is basically just, linear combination of the vectors. That's all. From the humble beginnings, okay, we are starting with very humbly, to the amazing things are going to emerge. Just think of everything that you can, like, this is just an analogy that this book author is saying. Just think of everything you can build with wood planks and the nails. Like, wood planks is just a wood, and nails means, like, the nails, right? So just think of it, that you can, what you can build with the wood planks and the nails. Everything, even the houses are created using the wood planks and nails. Everything, any furniture, houses, and you can even build the buildings using the wood planks and nails. Just like it, like, you can build the whole linear algebra using just these scalars and vectors. Okay, so let's just continue. Now, the very first topic that we are going to study is what is the linearly dependent vectors and what is the linearly independent vectors. Okay. For example, if I just give you these two vectors, tell me, are these two vectors are linearly dependent or these two vectors are linearly independent? What do you think? Sorry, let me go to that slide. Yeah. So what do you think? These two vectors which I have shown in the slide, which are linearly dependent or independent? Okay. So you can very easily see that these two vectors are linearly dependent. How? Because one of the vector is basically a multiplication of another vector, which means you will say that this 2 4 is a multiplication of 2 times of this vector. So that's what the linearly dependent vectors are saying. Basically, two vectors. Okay. Basically, this this linearly dependent vector is defined for the set of vectors. If a set is having just two vectors, it is very easy. If among two vectors you want to find out, just check whether using a linear combination or using a scalar multiplication you can get the another or not, right? So if I am just asking whether these two vectors are linearly dependent or not, you can very easily come up with the answer that by just checking manually that okay, this 2 is basically 2 into this, and similarly this 4 is 2 into this. That's why these are linearly dependent. Suppose instead of this 4, if I just have 5, then what will your answer? Let me know. Instead of this 4, if I just have 5, then are these linearly dependent vectors? No, right? These are not linearly dependent vectors. So I will say that you can very easily, just if the two vectors are given, then you can very easily find out whether these linearly dependent or independent vectors, right? But let's go to, maybe more than two vectors. So if you have two vectors, then I think you can very easily find out whether these are linearly independent or dependent. And if you have more than two vectors, then let's just see how we are going to do it. So before that, this property of linearly dependent and independent is defined for the set of vectors. Okay, is defined for the set of vectors, which means don't come to me and don't ask me whether this 1 2 4 or whatever the vector you have in your mind, whether this is a linearly dependent vector or not. Okay, I mean, don't ask me for a particular vector. Don't ask me for a particular vector. Ask me for a set. Ask me for a set of vectors. Okay, and then I will tell you the answer. So let's just build the basic step by step. So suppose if I give you these three vectors, and if I ask you whether these three vectors are linearly dependent or independent, by your intuition, what do you think? Till now, I have not given you any method, but by your intuition, what do you think whether these three vectors are linearly dependent or independent? Let me know. Okay, so these three vectors are linearly in what is your answers? Let me just check. Varun is saying not independent. Okay, Abdul is saying independent. Subhadeep is saying dependent. Dangerous Cloud is dependent. Anamika is saying dependent. Cool. Ankit dependent. Okay, few of the people are saying dependent, few of the people are saying independent. Okay, I do not care what you are saying. Reason being is that I have not told you the method, like how to check. I have not told you how to check, so I'm not expecting the answer, but just using the human intuition, I just ask you. Anyway, whatever is your answer does not matter to me. Let me just tell you whether these are linearly independent or independent. What you will be doing, you will be just, I mean, till now, since I have not told you any method, what you will be doing, maybe you will be just doing hit and trial. You will be just checking whether one of the vector, which is, let's suppose, 3 6 10, whether this is a linear combination of other vectors or not. Since you found out that okay, this vector is a linear combination of these two vectors, it's just a summation of these two vectors, that's why this vector can be represented as a linear combination of these two vectors. That's why what will I say? Can I say this vector is linearly dependent? should I say this vector is linearly dependent? Tell me, is this vector linearly dependent? Is this correct saying that this vector is linearly dependent? Since this vector can be represented using the linear combination of these two vectors. Answer is no. See, for a particular vector, we do not define these terms. I will say this set is linearly dependent, right? This set is a linearly dependent set. This set is a linearly dependent set of vectors. Why? Because see, till now I have not told you method, but yeah, like I just checked it out that okay, this vector is a linear combination of these two vectors. That's why these three vectors are linearly dependent vectors. What will I say? That I will say that these three vectors, not just one vector, okay, or not just two vectors. I will say this set of vectors or these three vectors, right? I will say these three vectors, are linearly dependent. Let me know if that is clear to everyone. That's just a basic definition that we are building upon. Okay. Now let's go to this, where what I'm saying, that instead of representing this vector, okay, instead of representing this vector as a linear combination of these two vectors, I can definitely represent this vector also. You might want to transfer, or you might want to send this vector here, and there will be a minus sign, right? So I can definitely represent, and there will be a minus sign here. So you might want to represent this vector. Does not matter. I can represent maybe this vector also. I can represent this vector also, right? So if you can represent this vector, then probably I can represent this vector also, this vector also. I mean, it's just that plus minus symbol, right? Cool. So now suppose I say that there is one vector where I have this set, okay? Suppose here, instead of the set that I had earlier, let me just remove it for now, and let me show you that what I mean to say. Instead of the vector that I just shown you earlier, suppose if this is the set of vectors that I have, now tell me whether these three set of vectors are linearly dependent or independent. Earlier I used to have 10 here, to be just recalling, I'm telling you. Now I have 9 here. Now tell me, if I have 9 here, then these set of vectors are linearly dependent or independent. Dangerous Clady is asking that what is the way to decide. I will tell you the way. Don't worry. Let's be with me. Okay, I will not skip even a single thing. I will tell you that how to check. Basically, you need to put all of this vector in a matrix. Then you need to check the rank. Okay. So what do you think? These set of vectors are linearly dependent or independent? These set of vectors are still linearly dependent. How? Because you have one of the vector which is 3, 6, 9. You have this vector which is 3, 6, 9. You can represent this vector as a linear combination of other vectors, which means you can represent 3 into 1, 2, 3, and then plus 0 into 2, 4, 7, right? Can you represent at least one of the vector? I'm not saying maybe all of the vector. You can represent this vector which is 3, 6, 9 as a linear combination of other vectors, right? So let's go step by step. Given a set of vectors, I can represent one of the vector which is 3, 6, 9 as a linear combination of other vectors. Now there are few questions that I want to ask. I want to answer. One question is that here, if I'm representing this vector as a linear combination of other vectors, now this 3 is okay to me. Suppose this is okay to me. Is this 0 okay? I mean, can I have 0 as a scalar? Which means, what I mean to say, let's suppose there is one vector, okay, that I'm representing as a linear combination of two vectors. Then what should be the coefficients? That's my question. Which means, can I have a 0 coefficient? Can I have a non-zero coefficient like that? So in earlier example, this was a 3 and this was 0. Are these coefficients acceptable to me? If I am having 3, 0, can I say that these three vectors are linearly dependent? So the answer is yes. Okay, answer is yes. Just listen here carefully that these coefficients does not matter to me. I will come to the formal definition. I will build all the basic blocks just in a while, but just be with me. Let me go in my way, because I know that how you will be getting to it, right? So here the first thing that I'm telling you is that you represent any of the vector as a linear combination of other vectors, and good thing is that coefficient does not matter to me, which means that this 3, this 0, this coefficient does not matter to me, which means coefficients could be 0, could be non-zero, could be 0 or non-zero. Let me know if that is fine to everyone. So coefficients could be anything, right? Now, okay. So what I'm doing, I have a vector which is this. I'm representing this vector as a linear combination of other vectors, and then I'm saying that this coefficients could be anything. Then if I can do it, okay, let's not worry about the coefficients. If I can do it, then I will say that this set of vectors are linearly dependent vectors. So now I hope the definition is making little sense, and I will just compile all of the things that whatever I'm saying. But for now, let me just know if these things are making little sense. Which means I'm saying here that if I can represent just one of the vector, okay, if I can represent just one of the vector as a linear combination of other vectors, then the set of vectors is linearly dependent. Let me know if this is clear to everyone. If I can represent just one of the vector as a linear combination of other vector, which means here I have represented this vector as a linear combination of other vectors. Now, some of you might be thinking that this is not important for gate or this is important for gate. Let me tell you that you have no idea that what is important for gate and what is not important for gate. So whatever, as I put the disclaimer earlier, that whatever I'm going to teach here is not anything which is beyond gate or not important gate, because I value your time and I know whether it is important for gate or not more than what you know. Okay, so because I have the experience, I know the subject, I have cracked the gate, and I know far more than what you know, the whether it is important for gate or not. Just because you have not studied the linear algebra in the way that I'm teaching, or in this way, that it doesn't make it less important. Okay, I will relate all of this concept to one very popular, very important thing in linear algebra in gate syllabus, which is ax equal to b. And once you understand this linear combination of the vectors, then ax equal to v will be just a cakewalk for you. Okay, this is just a byproduct. I mean, this is just using the fundamental things which are here. So let me know if this definition is making little sense to you or not. Right? So what I'm saying here is that if this particular thing, which means any of the vector, is a linear combination of other vectors, now coefficients I do not care, whether it is 3, 0, I do not care, then this set is a linearly dependent set. So let's make this more interesting. Let me ask you one more question. Can you represent this vector as a linear combination of other vectors instead of this vector? See what I did here, I just represented this 3, 6, 9 as a linear combination of other vectors. Now my question is this, that can you represent this vector as a linear combination of other vectors? Maybe some of you can do it very easily, and you people will say that yeah, there is nothing in this. Okay, I don't want to rotate it, so you will say there is nothing in this. What you just need to do, you will probably write it here, which is this 1, 2, 3, and then you will be writing, you will probably, I think, doing this there, which is 3, 6, 9, 1 by 3, 3, 6, 9, and then this will be just a 0, right? So yeah, you can definitely represent this vector as a linear combination of other vectors. This vector, I mean, you have represented W as a linear combination of other vectors. You have represented V as a linear combination of other vectors. Sorry, not V, U, right? You have represented U as a linear combination of other vectors, right? This is W, this is U. You have represented U as a linear combination of other vectors. Let me just ask you one last question, that can you represent V as a linear combination of other? Can you do 2, 4, 7 equal to something, something, and something plus something? Which means earlier if I wanted to represent this, I can divide by 3. But if you want to represent this, then can you divide by 0? Right? You need to divide with this coefficient. It seems like you cannot in this case, probably, right? So if you cannot represent this vector as linear combination of other vectors, then it doesn't mean that this set is linearly independent or something. See, the definition is very clear. If you can represent at least one vector, okay, if you can represent at least one vector as a linear combination of other vectors, at least one vector you need. This is extremely important, to be very honest, because once you study ax equal to b, you will get to know that here the trivial and non-trivial solutions are just coming from this definition, that you can represent at least one vector. At least one means you can represent W. I'm done with it. Okay, I do not need to even care whether you can represent U or not. And can you represent V or not? I mean, I do not care. You may represent, you may not represent. It does not make my linearly dependent set as independent or vice versa. Which means if I can represent at least one vector, then this set is linearly dependent. Let me know if we are settled upon this definition or not. So if there is a set, right? Let's suppose U, V, W, anything, right? Maybe other vectors, how they look like. Maybe PQR should be a good name. What do you think? Yeah, PQR may be a good name. Not so good, but what can I do if I do not have much alpha weight? So so let's say PQR. Then I will say that if I can represent just at least one vector, okay, if we can represent at least one vector as a linear combination of other vectors, then this set is linearly dependent. See, I'm emphasizing this too much because I need you to understand this. Because if you do not understand this, you will not get to know much things, right? So if you can represent at least one vector, this is important. Now let's just understand this for 15 to 20 more minutes. Okay, I'm just going to spend 15 more minutes just with the different examples, with the different way of looking at the same thing, so that you understand it very clearly that what do I mean by that. And then we will be solving. There is one AIMT one question. Do you remember there was one AIMT one question related to this? Then we will be solving that question. Let me first go through all the basic of the things, right, of the linearly dependent and linearly independent. Now suppose you have this configuration and I will just ask you, do you have at least one vector that you can represent as a linear combination? If you can tell me yes, I have at least one vector, let's not worry about the coefficient, okay, whether it is zero, it is non-zero, let's not worry about it. If you have at least one vector, then we are good to go. So Shyam is asking, sir, what is the range of coefficient to represent linear combination? Range is nothing, it should be just a real number, that's all, right? Okay, now let me give you these three vectors. Maybe strange looking, but this will make your concept very strong. Okay, so suppose if I have three vectors, can you represent these three vectors as a linear combination of some other vector? I mean, can you represent at least one vector as a linear combination of other vector? If you try doing this V, then V is a 2 into this, seems like it is 2 into this, but here it is not, right? It should be 3, 9, and here it is not. Can you represent any one of the vector as a linear combination of other vectors? If you're representing V, then tell me what are the coefficients. Okay, tell me what should I write here, what should I write here if you're representing V. Similarly, if you're representing W, then tell me what should I write here, what should I write here. Similarly, if you're representing U, then tell me what should I write here. So let me know what is your answer. If you can represent, then let me know what are the coefficient and what is the equation basically, right? If you cannot represent, that's fine. And if you can represent, let me know. Answer me quickly. What do you think? Yeah, great. So Sawadip is saying W equal to 0 into U and plus 0 into V, right? So Sawadip has given really a nice answer, which I really like. So that's why I'm just going to put his answer in the slides. Okay. So he is saying that W equal to 0 into U plus 0 into V. And that's correct. That's correct. Because I do not care about these coefficients. Okay. This could be anything. So can I say that this set is a linearly dependent set? Can I say this set is a linearly dependent set? Then the answer is yes. This set is a linearly dependent set. Why? Because I have at least one vector. See the definition. The definition is that if we can represent at least one vector, which is W in my case, right? See, I have W in my case, right? I can represent this W as a linear combination of other vectors. That's why I'm saying that this set of vectors are linearly dependent. I'm just going with the definition that I just told you, right? Cool. So these set of vectors are linearly dependent. Very nice. Now, since it is a zero vector, I can represent it as a linear combination of other vectors. That's why I'm saying this set of vectors are linearly. So again, UVW, this set of vectors are linearly dependent if and only if there is at least one vector. Okay, there is at least one vector such that the vector is a linear combination of other vectors. Coefficients could be anything. Tell me if this is true or false. A set containing a zero vector is always linearly dependent set. If the set is having a zero vector, which is also AIMT one question. Do you remember the AIMT one question? This was also the AIMT one question. A set is containing a zero vector is always linearly dependent. Tell me fast. Let's not wait for others to answer. Just tell me your answer. Yeah. Thank you, Subhadeep. Thank you, Sikhar. Sikhar is saying, sir, आप बहुत अच्छा पढ़ाते हो. Thank you for giving us incredible knowledge. Thank you so much, Sikhar. So everyone is saying true. I'm very glad to see your answers. So everyone is saying true. So that's why I can just paste all of your answers here, because all of you are saying that this, in fact, it is right. So this thing is actually true. So because I can, if I have a zero vector, then I can represent this as a set of I mean, if I have a zero vector here, then I can represent this is zero into any vector I have, zero into any vector I have. So that's why this is a linearly dependent set. Tell me if this is okay. If I have these three vectors, then how will I be able to represent? Then see, I told you that if you have a zero vector, then you can definitely represent with a 0 0 coefficient. But there are multiple coefficients also possible, right? In this case, this is also one of the set of coefficients that I'm having, which is perfectly fine to me, right? So if I have a zero vector, definitely this set is linearly dependent. Let's just build this basics more clearly. Suppose I have these three vectors. What do you think? These three vectors are linearly dependent vectors or independent vectors? So what you can do, you can try representing these three vectors as a linear combination. So you will say that okay, this 3 6 9 is 3 into this, but 0 into this. That's fine because the coefficients could be anything. But can you represent this vector as a linear combination of other vectors? Can you represent? Maybe, may not be. Like I actually do not know, but it looks like you. I mean, you go with this approach, then you will not be able to divide the 0. Then may not be, right. Okay. So we cannot represent this as a linear combination of other vectors because this is 0 here. Now, Now, suppose if I have this v1 equal to, okay, now I'm going with the abstract thing, which means instead of giving me the actual numbers, I'm just writing v1, v2, c1, c2. I hope that's fine. Can I represent v2 as a linear combination of other vectors or not? If I just ask you this question, then you will just ask me in counter. You will just ask me, if I just ask you that can I represent v2 as a linear combination? I'm giving you that v1 is a linear combination of other vectors, and if I just ask you, can you represent v2? Then what you will just ask me? Can anyone tell me what you will be asking me as a counter question? What you will be asking as a counter question? You will be asking that do you have this C2 as 0 or non-zero? Which means if it is 0, then you cannot represent. If it is non-zero, then you can represent, right? So if C2 is not 0, then definitely yes, right? Is this clear to everyone? If C2 is not 0, then definitely yes. Let me know if this is true or this is false. If a set of vectors are linearly dependent, see, once you understand this set of vectors, linearly dependent, independent, then you will automatically be doing this ax equal to 0 very, very trivially. A set of vectors are linearly dependent, then there is at least one vector which we can represent as a linear combination of other vectors, whether it is true or false. Right? This is true. Easy. So that was true. So let me just write it here. This is true. Let me go to the next question. Tell me whether this is true or false. If a set of vectors are linearly dependent, then all vectors in that set obviously can be represented as a linear combination of other vectors. Whether this is true or false. Okay, just think about it carefully. And sorry if I'm just making some noise here, but since it is in our best of our interest, that's why I'm just saying it. Just hit the like button, and there are like almost 50 people here, and I can just see the lesser likes. So just hit the like button, because then only it will get to recommend other people, and that will be beneficial for us. If we are putting so much of effort just for you, then we just expect you to do the minimal things, which is just hitting the like button or putting some comments. So after this lecture, not here in the live lectures, but after this lecture, once the live streaming ended, just comment it out that you have understood everything, so that later when people come, then it will get to know, because many of the videos on our channel are very very good, too good. Just for 1 hour of the video, we have spent even 2 days. Have you seen there is one video of Handle and Bible prefix in compiler design? in compiled design. I've actually spent just 2 days to understand that handle, and I do not see like more than 5 comments. So it really, I mean, do not feel that much nice, because for other videos there are many comments for other instructors which are even not that nice, and that's why we are just requesting you. Hope you understand. Okay. So now tell me whether this is true or false. Yeah, this is false, right? Because it is saying all, that's why it is false. Now, just to your surprise, you know what? This particular, not directly in the true false, but I think there was one MCQ that has been asked in GATE. Okay, this same question has been asked in GATE, and they have misinterpreted it, and by mistake they have written all here. They wanted to write any. Okay, they wanted to write at least one, I think, but I do not remember that particular question or the year of that particular question. But the same thing, the same question has been asked in GATE, PYQ. Do anyone remember that it has been asking GATE PYQ? You might not be able to remember the year currently, but do you remember it has been asking GATE PYQ with wrong interpretation? It was a surprise to me. I mean, this happens in GATE, but yeah, that should not happen for these trivial things. Cool. Now, suppose if I say that UBW, we are able to represent any of the vector. Is this correct? Is this true or false? If I'm saying any of the vector of your choice, can you represent any of the vector of your choice as a linear combination of other vectors? Then answer is no, right? Any of the vector, no. But at least one, then it is correct. Now, I think time has come to solve this gate, sorry, not gate, this AIMT questions, previous questions. So this is AIMT1 question. AIMT1. All India mock test go classes mock test 1 question. So what they're asking, let UI is the vectors in Rn for I equal to 1 to 4. Which of the following options is or are correct? If U1, U2, U3 is linearly dependent, so is U1, U2. What do you think? Let's pick each option one by one and tell me if this option is true. What do you think? If U1, U2, U3 is a linearly dependent, so is U1, U2. See, suppose U3 is 0 and U1, U2 are not linearly independent, not linearly dependent, which means U1 may be 1 to 3 and U2 may be 2, 4, but at the last it is misbehaving. Maybe let's suppose 2, 4, 2, 4, 7, something like this, right? And U3 is 0, 0, 0. They are linearly dependent or not? Since this is having a 0 vector, then definitely it is linearly dependent. All of this, I mean, this set is linearly dependent set, right? Since they are linearly dependent, then if I remove one of the vector, let's suppose U3, then are these linearly dependent? Then answer is no, right? Need not to be. So it is then U1, U2, then need not to be. So it is not always correct. So that's why A is false. Let me know, have you understood this? Take this example where U1 is this, U2 is this, and U3 is this. Right? Take this example and let me know if you have understood. Cool. Now, okay. Now let's go to the next option, which is U4 is not a linear combination. Let's suppose if U4 is not a linear combination of this, then U1, U2, U3, U4 is linearly dependent. Let's see this. If U4 is not a linear combination of this, what they are saying that if you cannot represent U4 as a linear combination of this U1, U2, U3, I mean, you cannot, because U4 is not a linear combination, so you cannot represent U4 as a linear combination of this, then certainly they are saying U1, U2, U3 is a linearly independent. Is this true? Can they be linearly dependent? Of course, right? You just have a linear dependency between U1, U2. You do not even care about the U4, which means let's suppose U2 equal to 2U1. Then you will say U2 equal to 2U1 plus 0 into U3 plus 0 into U4, which means you do not care about U3, U4, right? They are saying that if U4 is not a linear combination of these three, which means U4 cannot be represented as a linear combination of these three, then then it certainly means that they are linearly independent. No, u1 u2 could be linearly dependent because of u1 u2, because just because of u1 u2 the whole thing is linearly dependent, right? So that is in option C, I think, right? In option C, or option D, I think they are talking about this. If the subset is linearly dependent, then the superset is linearly dependent. Yes, that is true. Because adding this u4 does not harm you, because you can always have 0 into u4, right? See, whatever earlier representation you had, and then you can just add 0 into u4, because adding the extra vectors does not harm you. So if this is linearly dependent, so earlier if that was the linearly dependent, which means something into u1 or something into u3, then you can always add u4. So if this was linearly dependent earlier, then adding the vectors does not harm you ever. So that's why D is true. D is true. Any set containing 0, that is also true. If u4 is not a linear combination, then if you cannot represent u4 as a linear combination of these three, then they are saying that you cannot represent others also. No, this is not even the logic, right? I mean, you can definitely represent u1 u2 as a linear combination of each other. That makes the whole set as a linear independent set, right? Right. Okay. So option D is not clear to Yash, I think, right? So let me just tell you what is the option D. Option D is saying if u1, u2, u3 is linearly dependent, which means if a subset is linearly dependent, then a superset is also linearly dependent. That's what they are saying. If a subset is linearly dependent, then the superset is linearly dependent. Which means if subset is linearly dependent, let's suppose u1, u2, u3, these are linearly dependent. What does this mean? It means it is given, let's suppose these are linearly dependent. Then what does this mean? Then it means that you have some vector, maybe u1, maybe u2, at least one vector basically you have from this, that you can represent as a linear combination of other vectors, right? I mean, I do not care about these coefficients, honestly. Could be 0, could be non-zero. But yeah, this at least one vector here, right? At least one vector can be represented as a linear combination of other vectors. Now they are saying, can you add in this set, can you add u4 also? Or can you say this is also linearly dependent? Yes, you can add u4. How you will be adding? See, they are saying, can you add u4 also? Then my answer is yes. How you will be adding? You will say that yes, you can represent, now also you can represent at least one of the vector, which is again u2, let's suppose, as a linear combination of other vectors. Put the 0 in the u4, right? Earlier that was the case, that was given to you, right? It is given basically, right? It is given that these are linear dependent. Now they are saying, can you add one more vector, maybe two more vector, maybe three more vectors, right? Then they are saying the superset, which means adding adding extra vectors, does it harm your linear dependence? No, it does not harm me, because I will always have 0. I mean, this is just one of the options that I will be having. Maybe other coefficients also satisfy, but I do not care, right? Okay, great. Now let's just move further, which is linearly independence. Hope you have understood linearly dependence. Now we will be understanding linearly independence. Then we will be moving to the gate PYQs related to AX equal to B. You will not be even realizing that we are solving AX equal to B or AX equal to 0 just using the definition of linearly dependent and linear independent. So the best is yet to come. Okay, the best is actually yet to come. Let me just go step by step. So what is linearly independence? Fortunately and thankfully, this definition is very simple. A simple definition is saying that something, yeah, a set of vectors are linearly independent if and only if they are not linearly dependent. That's the only definition that we have. अगर वो linearly dependent नहीं है, then they are linearly independent. Or vice versa. If and only if means vice versa. Basically, either the set is linearly dependent or the set is independent. If this is dependent, it cannot be independent. If it is not dependent, then it is independent. Basically, linearly, if you know whether it is linearly dependent or not dependent, I mean, you know the independence, right? I mean, it is opposite to each other. Either it is dependent. If you say it is not dependent, then what does this mean? You are saying it is independent, right? That's all. So this is in the layman terms, but we will understand it little more carefully so that we can solve the questions like AX equal to 0 and AX equal to B. Now you might be wondering that how these two things are related, but actually the whole of the linear algebra just fall into one place once you understand that how these two things are related. Let me know if things are clear and we can move further. And my voice is clear or not? Okay. Is my voice clear? Cool. Let's just understand this more carefully, that what does this linearly dependence means. So what will I give you to? Let's suppose I give you this equation to you. Okay. Suppose I give this equation to you. What does this equation says? This equation says that this C1, I mean C1s are scalar, okay, the Ci's are scalar, Vi's are vectors. So whenever I write any symbol, maybe alpha, beta, x, y, z, anything I write, then you should always ask me whether it is scalar or it is vector. It is a matrix, scalar, vector, like that. You should always ask me. Although the notations are very, very much formulatic, systematic, which means whenever I use C, Ci, C1, C2, C3, A1, A2, A3, small a1, A2, A3, most, no, not A generally I use for the vectors also. I mean, the text was used for the vectors. If I use the Vi, then generally it is for vector, it is for scalar. If I use capital A, maybe capital M, then generally it is for the matrix. But yeah, you should be clarifying that to me. Okay. You should be asking that question to me, whether it is a vector, it is a scalar, like that, right? Okay. So suppose these are the scalars, C1, C2, C3 are scalar, V1, V2, V3 are vectors, and suppose someone give you this equation. And then whenever someone give you this equation, you just ask me, you just ask that person one question. You just ask one question, which is that, can you give me, can you please help me, or can you give me at least one Ci such that Ci is not equal to 0. Which means you are asking just a very simple question to that person, that can you give me one Ci which is not equal to 0? Suppose that person says that yes, I have C1. Okay. Suppose that person says I have C1 is not equal to 0. Okay. C1 is not equal to 0. You will say, oh, great. If C1 is not equal to 0, what will I do? I will represent V1 as a linear combination of other vectors. Maybe you will transfer all of this to that side. Maybe C1, C2, V2 plus, like that, right? If C1 is not equal to 0, then what will you do? You can represent V1 as a linear combination of other vectors, isn't it? So whenever someone gives you this equation, okay, this equation, then you just ask one question: can you give me one of the scalar which is not 0? If you give me, let's suppose C1 not equal to 0, then I will be very happy. I will be just representing, if C1 is not equal to 0, then I will be just representing V1 as a linear combination of other vectors. I mean, I do not care about the coefficients, but yeah, I know that these can be represented by the set of other, something like this, right? But I do not care about the coefficient. Let's not worry. So you can represent V1 as a linear combination of other vectors if C1 is not 0, right? So you can say that you can represent V1 as a linear combination of other vectors. Let me know if that is clear. If C2 is not 0, you can represent V2 as a linear combination as other vectors, right? You can represent V2 as a linear combination of other vectors. If C3 is not 0, similarly you can represent V3 as a linear combination of other vectors, like that, right? Okay, great. Now, if someone gives you this kind of equation, which means someone give you this kind of equation, then you will be just asking, can you help me with at least one Ci? If you just help me at least one Ci, I can represent that vector as a linear combination of other vectors. So that's all. Now, it means that if someone help you with actually at least one Ci, okay, which means you ask that person, do you have at least one Ci? Do you have at least one Ci which is not equal to 0? You just ask a very simple question. Okay, nothing very fancy. Just ask just a very simple question. Can you help me with just one Ci which is not equal to 0? And this is very powerful, a powerful thing actually you are asking to that person. Let's suppose the person is saying, oh sorry, I cannot help you. Okay, maybe the person is, I cannot help you, cannot give any Ci which is not equal to 0, which means all of the Ci's are actually 0, which means all of Ci's. So let's suppose the person is saying that C, all of the Ci's are equal to 0. I cannot help you with any Ci which is not 0. Okay, it means you cannot represent any vector. You cannot represent Vi. Can you represent Vi? No, because this coefficient is also 0. So that's why you cannot divide the 0, right? So it means you cannot represent any vector as a linear combination of other vectors. See, if C1 is not equal to 0, C1 is 0, okay? C1 is 0. Then it means what? Can you represent V1? No. If C2 is also 0, can you represent V2? No. If C3 is also 0, there, I'm saying if everything is 0, can you represent any of the vectors as a linear combination of other vectors? No. Right? If let's suppose this is not 0, if let's suppose one of them is not 0, you do not care what is that value, or everything else is 0, right? Okay. Let's suppose one of them is not 0. Let's suppose C1 is not 0. Suppose C1 is not 0. This is not 0. I hope this is clear. This writing is clear to everyone. This C1 is not equal to 0. Suppose this C1 is not equal to 0. Then what you will say? If C1 is not equal to 0, I do not care about the other coefficient. Okay, I do not care about the other coefficient. I have at least one vector which is not equal to 0. I will be writing V1 as 1 upon C1 into something. Whatever other coefficients are, I do not care. If C1 is not equal to 0, in this equation, I can represent V1 as a linear combination. But if everything is 0, then I will not be able to. Is this clear to everyone? Let me know. Right? So I hope that is clear. Okay, so I can see a few of the comments which are saying clear. So I just need to take care of just one non-zero coefficient. If I have one non-zero coefficient, then I can represent that vector as a linear combination of other vector. Now suppose if you ask the same question to some guy and that guy is saying that all of the CIs are actually 0, then what you will say? You cannot represent any vector as a linear combination of other vectors. That it means that these vectors are linearly independent. These vectors are linearly independent. Which means if you cannot represent, the definition is very simple. If you cannot represent any of the vectors as a linear combination of other vectors, if you cannot represent any vector as a linear combination of other vectors, then this is linearly independent. Is this making some sense? So what you will do, you will just ask, given this equation, you will just ask, do you have a non-zero CI? If someone give you some non-zero CI, you can represent that vector. Let's suppose they give you C1 not equal to 0. You can represent V1 as a linear combination of other vectors. If they give you C2 not equal to 0, you can represent V2 as a linear combination of other vectors. Similarly, if they give you C3 non-zero, you can represent B3. But they say no, everything is 0. Then can you represent anything? No, right? So that's why these vectors are linearly dependent. If they give you some CI, then if they give you some CI, then linearly dependent. If they say that all of the CIs are 0 basically, then you can not represent. Then it means they are linearly independent. So let me go step by step. Don't worry, right? What will I do? I will give you this equation. I will just ask you. You just ask me basically C1 is 0 or not. I say okay, it is not 0. You are very happy. You can represent V1 like. At least is this slide clear? Don't worry about whatever I have told till now. Okay, just take a breath and let me know if this slide is clear. Meanwhile, let me also drink the water. And I will clarify this thing because this is very, very, very much related to AX equal to B, which is the core of linear algebra as per the GATE syllabus. And not just a GATE, in the interviews and these things, they will be just asking you these things, right? So I have got many messages after the GATE. I have got many feedbacks after the GATE that they are just saying that whatever we have taught, like you have taught in the LA class, they have just asked the same thing. And actually, this is just a linear algebra at the core level. If you do not just by heart some formulas, if you just try to understand that with the core level, then this is the linear algebra that you should be studying. Okay, so it's really nice to see that you people can answer this. So now you understood this slide at least, right? If C1 is not 0, then you can represent V1. Cool. Now, similarly, if they give you at least one of the CI which is not 0, then can you represent this BI? Let me know. Let me know if you can represent that VI. Obviously, yes, right? Represent means that linearly dependent. So when I'm saying can you represent that VI? Can you represent? Actually, I'm just asking whether it is linearly dependent. I mean, represent. If you can represent, then it is linearly dependent set, right? Represent means the moment you represent, it is linearly dependent, right? The moment you represent, the moment you say that this is the equation that exists in my in my set of vectors, then these set of vectors are linearly dependent, right? The coefficients could be anything. See, again, the coefficients could be anything. I do not worry about the coefficients. So if someone gives you this equation, then you just ask me, can you give me one CI? If they give you one CI, you can represent linearly independent. They are not able to give you any of the CI. You cannot represent these are linearly independent. If you can represent dependent, right? So just see this slide, which is very very important. They will give you this equation. Then you just ask them, can you give me at least one CI, which is not zero? If they say yes, then tell me what should I write here, dependent or independent? If they say no, then what should I write here? Tell me one in place of one, what should I write? In place of two, what should I write? If you tell me, then you have understood this linear dependent independent, and I can take at least one deep breath that okay, you have understood, and I can at least be very happy. Let me know. Let me know. This one is what should I fill in place of one? What should I fill in? Okay. There is some issue related to volume. Let me know. Okay. Now the volume should not be the issue. I just kept this mic little closer to me. By the way, these are the bottles of Go classes that we have actually, I mean, ordered so that if you get any top rank in any of our mock test or some AIMT All India mock test, then we will be just gifting you these bottles. This could be the motivation to appear for All India mock test, if that makes sense. Okay, so yes is saying one is linearly dependent and two is linearly independent. Okay. Alman is saying linearly independent, two is linearly independent. Cool. Let's just see the answers. So many of you have given the correct answer, I think. So if they give you just one CI, right? If they give you one CI, then linearly dependent. If they say no, I cannot give you one CI. It means what? It means what? All of the CIs are zero. All of the CIs are zero, right? Then it means linearly independent. Let me know this definition is clear to everyone, right? So here linear dependent, here linear dependent. See, no means what? They cannot give you at least one CI, which means this equation is getting satisfied, but by putting all of the zeros, right? If you obviously put this is a trivial solution, right? Trivial means like this is obvious solution. Now that if you put everywhere zero, if you put this zero, this zero, this zero, right? Everywhere if you put zero, then definitely you will be getting zero. There is nothing fancy in this, right? So which means if that's the only thing by which you can make the whole equation zero, which means there cannot exist any non-zero CI. You have to put all of them as zero. Then these are linearly independent. Which means that given this equation, okay, given this equation, which means that this equation is satisfying. Which I'm not saying that this equation is not satisfying, but the way to satisfy this equation is only one way, which means by putting all of them zero. You put here zero, you put here zero, you put here zero, you put everywhere zero, then only you are coming up with the zero. तो फिर क्या ही फायदा, मतलब अगर अगर यही करके जीरो लाना था तो फिर क्या ही फायदा इस इक्वेशन का, which means this equation is very trivial. So if you have to put all of them zero, that's the only way to make it zero. Then these set of vectors are linearly independent, right? These set of vectors are linearly independent. See, I don't want to make it complicated, but I want to make it clear. So that's the difference. Just to avoid making complicated, I cannot skip these parts. So I want to make it more clear. That's why let me just ask you one question. And unfortunately, you all might be wrong in this question. I mean, you all might say the answer is. I mean, you all might give you the wrong answer, which is okay to me. But then I will explain you. Okay. Suppose this equation is given to you, and I'm asking directly a formulatic question, which means I'm not hiding any details. The question in the way that they can ask you in the exam. Every detail I'm presenting to you, and then you have to decide whether it is true or false. Okay. So suppose that I'm asking true or false. I'm giving you this equation saying a set of vectors satisfy the following equations. A set of vectors v1, v2, vn satisfy this. where where all Ci's are 0. I mean Ci's are scalar and which are 0. Then V1, V2, this set Vn is linearly independent. Let me know if this is true or false. Yes, Rahil. So Rahil saying Ax equal to 0 is in the system of equation is the same. The 0 vector is trivial solution. Yeah, that I will connect the dots. Okay, just I'm going to connect the dots. Let me first make it very clear that you have understood the things very, very nicely. Then I will be connecting all the dots. So what do you think? Okay. So Dapi is saying true. Mr. Singh is false. Sunuj is saying false. Everyone, please give me the answer. Do not hesitate to give me the answer. Okay. Just whatever is coming into your mind, because that's the way you will be interacting, and that's the way I will be knowing your names. That's the way we will be interacting even after the gate once you get the top rank, right? So Rajesh is saying true. Harish is saying false. Anamika true. Baba Yaga, I mean there's a username which is saying false. Okay. So let's just see if this is true or false. This is the exact question. Suppose that's what they are going to ask. They're saying a set of vectors are satisfying or satisfies or whatever. Okay, satisfy this equation where all Ci's are 0. Then this is linearly independent. Actually, this particular statement, okay, is not telling me anything at all. Not telling me anything at all. Why? Because if all Ci's are 0, then any set will satisfy this equation. Linearly dependent will satisfy. What this paragraph is giving to me, not telling me any information at all. I cannot definitely say it is linearly independent, maybe dependent. I do not know. Right? So I will connect dots. Don't worry. Don't think that I'm teaching whatever I taught you just now was wrong. See, if they're saying that this set of equation is I mean this equation is getting satisfied by vectors where all Ci's are 0. Obviously, everyone can satisfy this equation, right? I mean either this is linearly dependent or linearly independent, does not matter to you. Everyone will be satisfying this equation. So this is not telling me any information, not driving any information, not telling anything about the set. Right? This is not telling me anything. So what will tell you? If they say, let me ask you another question. So see, this is false. Reason being is this is not telling you anything, first of all. Okay. Now let me ask you a question where they will give you some information about the set. How? They will say a set of vectors satisfying. Okay, so currently it was not telling, but let me just modify this statement little bit, and then let me tell you that that it will make some sense then. Okay, suppose they say a set of vectors v1 to vn satisfy this equal to 0. Okay, and this, okay, let me just add one word here. Satisfy, they say the satisfy this where all Ci's are 0, and then before that if they say this satisfy this equal to 0 only when all Ci's are 0, where only when all Ci's are 0, which means they are saying that a set of vectors are satisfying, which is good. I mean the set of vectors are satisfying this equation, but only when all Ci's are 0. There is no other solution, which means that you cannot have any non-zero Ci. Right? They are saying that you are having equal to 0 only and only when all Ci's are 0, which means you cannot have. See, here they are clearly saying that you cannot have any non-zero Ci, right? So it means that here this equation is getting satisfied, which is good. But now they are saying you are satisfying only when all Ci's are 0, which means you cannot have non-zero here. This is not the possibility. You cannot give me any Ci which is 0, non-zero. Since you cannot give me any Ci which is non-zero, it means all Ci's are always 0. Not just for the coincidence, not just for this equation, they are always 0. I mean, if you want to satisfy this equation, then this is the only solution. All Ci's are 0 is the only solution. That's what they are saying. You're getting my point? See, what they are saying, let me just make it more clear. See, generally, if this equation is given to you, what do you ask? Okay, do you ask, do you have, you just ask one question, do you have one CI? One non-zero CI? If they say yes, yes, you will say great. Vi can be represented as a linear combination. If they say no, it means all of the CI must be zero. Then it means linearly independent, isn't it? That's what we have studied till now, right? That's what we have studied till now. Now let's just see that what they are saying. They are saying that you are satisfying only when all CIs are zero, which means you are asking a question to that guy, do you have at least one CI which is non-zero? They will say no, 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 I can satisfy only when all CIs are zero. Then it means that you are saying no, 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 and CI is non-zero, CI does not exist. If non-zero CI does not exist, then you will say linearly dependent. Earlier I said that this is getting satisfied where all CIs are zero. Yeah, I mean, if I just ask that guy, do you have any non-zero CI? It will say that, okay, I don't know, maybe, may not be, but I know that if all CIs are zero, then I'm satisfying. Maybe non-zero, in case of non-zero, I'm satisfying or not, I don't know. Because they are not saying that this is the only solution. They are saying this is just one of the solution, which is actually trivial solution, right? So they are saying that this is just one of the solution. They are not giving the information about all the solutions here, right? They are saying that this is just one of the solution where you put all of them zero, you will get the zero. Great, right? They are not telling me that whether the CI can be non-zero or not. They are not saying that if there can be non-zero or not. But here they are saying, clearly saying that there cannot be non-zero. They are saying only when all of the CIs are zero. You're getting the difference? See, what I'm saying here, if they give you any set of vectors, okay, any sort of set of vectors, then you will be asking CI that whether do you have one CI? Do you have one CI? If they say that, okay, this set of vectors, the only solution to this set of vectors is the trivial solution, right? The only solution means the values of C1, C2, C3. The only solution to this equation is trivial. First of all, solution means values of C1, C2, C3, right? Trivial means that they are zeros, right? C1, C2, C3 are zeros. They are saying only the only solution is that they are zeros. Then it means that they are linearly independent. Suppose they say that the solution to this equation is basically, the solution to this equation is all CIs are zero. Okay. Suppose they say the solution to this equation is all CIs are zero. All CIs are zero. Then can you say linearly dependent or independent? See, that's the very trivial thing they're telling to me. They're not adding any information to my knowledge. They are saying the solution to this equation is all CIs are zero. भाई ये तो मुझे ही पता है कि ऑल CIs are zero. टेल मी कि नॉन जीरो भी है कि नहीं है, राइट? मतलब ये तो सबको पता है ना कि जीरो पुट करने से जीरो आएगा ही आएगा. मुझे ये बताओ कि नॉन जीरो से जीरो आ रहा है कि नहीं आ रहा. In which I am interested in, right? I'm interested in whether you can put the non-zero, still get the zero. If you can do it, then this is linearly dependent. Otherwise, it is independent. If you are saying कि zero put करने से zero आएगा, what you are telling to me? You are not telling any information to me. You are just giving me a trivial information that the solution to this equation is CI equal to zero. हाँ, ये तो पता है, मुझे भी पता है, right? If you say the only solution, which means कि non-zero से नहीं आएगा. अगर मैं इतना sure हूँ कि non-zero से नहीं आएगा. See, first of all, this is, I cannot say anything. We don't know, right? We don't know. Okay. बट अगर वो बोलते हैं कि ओनली केवल जीरो से ही आता है, नॉन जीरो से नहीं आएगा. ओके, कोई भी नॉन जीरो रखो तो एकदम बात बिगड़ जाएगी. नॉन जीरो से नहीं आएगा तो मैं श्योर हूँ वो नॉन जीरो से नहीं आएगा, मतलब सीआई नॉन जीरो नहीं हो सकता, मतलब लीनियर इंडिपेंडेंट है. वो बोलेंगे जीरो से आएगा, वो तो मुझे भी पता है ना, मतलब सबको पता है कि जीरो से आएगा. दिस इज व्हाट आई एम ट्राइंग टू से, राइट? So Sar is saying, what if CIs are alternate sign? Why the alternate sign and these things will matter? I mean, you can put any CI. The vectors could be different. Right? V1, V2, V3 are not same. I mean, it could be anything. So anyway, okay. I hope you are understanding. Let me know if that is clear to you, because that's very very important. That's why I'm putting so much emphasis on this. ठीक है, ये समझ में आया ना? मतलब कोई भी इक्वेशन दे रहे हैं, हमें ये पता होना चाहिए नॉन जीरो से आ रहा है कि नहीं आ रहा. मुझे नॉन जीरो में इंटरेस्टेड हूँ, मैं जीरो में इंटरेस्टेड है ही नहीं. आई एम नॉट इंटरेस्टेड कि इसका जीरो सॉल्यूशन है कि नहीं है. मुझे पता है कि इसका जीरो तो है ही है. मुझे बताओ नॉन जीरो सॉल्यूशन है कि नहीं है. राइट? अगर वो क्वेश्चन में ये बता रहे हैं कि इसका एक जीरो सोल्यूशन है, वो तो मुझे भी पता है। मुझे ये बताओ नॉन जीरो है कि नहीं है, मुझे ये इन्फॉर्मेशन दो, डायरेक्टली इनडायरेक्टली कैसे भी दो, बट मुझे ये बताओ कि नॉन जीरो सोल्यूशन है कि नहीं है, राइट? सीआई नॉन जीरो हो सकता है कि नहीं हो सकता? जीरो हो सकता है, वो मुझे पता है भाई। यू आर गेटिंग माई पॉइंट? तो इफ दे आर सेइंग कि ओनली सॉल्यूशन, मतलब वो इनडायरेक्टली नॉन जीरो के बारे में बता रहा है कि नॉन जीरो सॉल्यूशन नहीं है, राइट? क्योंकि जीरो ही ओनली सॉल्यूशन है। ओके, कूल, आई होप यू अंडरस्टूड, राइट? So let's just see here. So if they say only trivial solution is possible, which means मतलब अगर देखो just a last thing I'm telling you, last time I'm telling you कि अगर वो कभी भी ये क्वेश्चन देते हैं, मुझे जीरो सॉल्यूशन में इंटरेस्ट है ही नहीं है, मुझे बताओ नॉन जीरो है कि नहीं है, राइट? आई वांट टू नो, या फिर हिंदी में लिखूं इफ यू आर कंफर्टेबल, मुझे ये बताओ, yes, मुझे ये बताओ कि नॉन जीरो को तो मैं इंग्लिश में लिखता हूँ, ठीक है? कि नॉन जीरो है कि नहीं। जीरो का मत बताओ, जीरो का तो मैं क्या ही करूंगा जान के, मतलब जीरो तो बहुत ट्रिवियल चीज है ना। मुझे ये बताओ सीआई नॉन जीरो हो सकता है कि नहीं हो सकता? डायरेक्टली बताओ, इनडायरेक्टली बताओ, आई डू नॉट केयर, राइट? तो डायरेक्टली इनडायरेक्टली आई डू नॉट केयर। ओके, तो सपोज दे गिव यू दिस इक्वेशन, दे आर सेइंग ओनली ट्रिवियल सॉल्यूशन इज पॉसिबल, मतलब नॉन जीरो नहीं आ सकता, केवल जीरो। ट्रिवियल मतलब जीरो, ट्रिवियल का मतलब होता है जीरोज, ओके, जीरोज। इफ ओनली जीरोज आर पॉसिबल, इट मींस दे आर लीनियरली इंडिपेंडेंट, ओके? कैन यू, ओके, आई थिंक दिस इज क्लियर टू एवरीवन। Cool. Now we are about to build our foundations. I mean, we are almost done with the foundations with ax equal to b, which means now we are about to go for ax equal to b. Now, whatever we have just studied about the linear combination, independence, dependence, this all will be just relating to this ax equal to b so nicely, so smoothly that you will not be able to even differentiate that this is ax equal to b, or linearly dependent or independent thing that we have just studied. Okay, that's so nicely it is going to relate. But before that, let me know if you have any doubt. Let me know if you have any doubt. Then we will move further. Okay. Okay. Thank you. Thank you, yes. So, yes is saying beautifully explained, sir. Thank you so much, yes. Okay, Mr. Singh is saying no doubt. Anamika is saying no doubt. Cool. Let's just move further. Now, just before going to x equal to b, I just want to give you one more information, and then we will be jumping to x equal to b. Right? Now, you know what is linearly independent, what is linearly dependent, right? Little bit you know, may not be much, but little bit you know. Now let's just ask this question: can we have more than two independent vectors in R2? Which means in R2 the vectors will look like this. I mean, two dimension 1, 2, 3, 5 like this, right? R2 the vectors will look like this. Can you tell me whether this set is linearly dependent or independent? What do you think? If I just ask you whether this set is linearly dependent or independent. See, in R2, if we have more than two vectors, which means maybe anything. Let me just give you one example. Let's suppose you have more than two vectors. Let's suppose these are the three vectors that you have. Okay, first vector is 1 0, and second vector is 0 1, and third vector is 5 7. Let's suppose these are the three vectors that you have. Now, I want to ask you, do you know, or can you tell me whether these three vectors are linearly dependent or independent? See, I have not told you any precise, any systematic way till now to check, but I'm just going with the intuition because we are just building the intuition till now, and linear algebra is all about the intuition. Obviously, there are systematic methods, there are algorithms like Gaussian elimination, finding the rank, and all, which we will discuss. But let's just first build the intuition, okay, so that you will get to understand those algorithms or those methods very nicely. Now, if I give you these three vectors, then if I just ask you, can we have more than two independent vectors in R2? Then let's suppose I give you these three vectors. Then you will say that okay, this 5 7, you can represent this 5 7 as a linear combination of this vector and this vector. How? You can represent very easily. You will say this is 5 into first vector and 7 into second vector, isn't it? And not just 5 7. You give me any vector with instead of 5 7. Okay. Instead of 5 7, you give me any vector. I can represent that vector as a linear combination of these two vectors. So suppose, okay, so you give me any vector. I'm not worried about that vector. Let's suppose you give me any vector in general. Let's suppose you give me alpha beta. Okay, you can pick any value of this alpha, any value of this beta. So if you give me alpha beta, I can represent alpha into something, and alpha into the first vector and beta into the second vector, right? So I can definitely say that if whatever you are giving to me, okay, I can represent that vector as a linear combination of these two vectors, which is 1 0 and 0 1. So definitely with these two vectors, at least I know that whatever extra vector you are going to put, this set is going to be linearly dependent, right? So whatever extra vector you are going to put, this set is going to be definitely going to be linearly dependent. If there are three vectors here, yeah, two of them happens to be this, that's okay. But I will come to the more concrete point. Okay, so if there are three vectors like this, then definitely linearly dependent, right? Because you give me any vector. If you give me 5 7, I will give you the coefficient which are 5 7 itself, right? If you give me 5 7, I will give you the coefficient which are 5 7. If you give me let's suppose anything, maybe do I have example? Okay. Also maybe if you give me alpha beta, then I will be having the coefficient alpha beta. You give me 3 5, I will be having the coefficient 3 5. You give me any vector here, this vector could be anything. I will say this set is linearly dependent set, right? Right, great. Now, not just this set, you take any three of the any three vectors in R2, this will be linearly dependent. So basically, currently I have these two vectors which are little convenient to me, some special vector I can say, or maybe convenient vectors I can say, which is, let's suppose this is 1 0, this is one of the vector, another vector is 0 1. Okay, suppose these two vectors which I'm just calling convenient. Why I'm calling convenient? Because the third vector, whatever it is, the finding the coefficient is very easy to me, right? If this is alpha beta, the coefficients are alpha beta. How easy it is to find the coefficient. If that was 5 7, the coefficient was 5 7. So that's why I'm just calling these two vectors as a convenient vectors. Okay, so with these two convenient vectors, whatever the third vector you have, you are definitely going to say that these set of vectors are linearly dependent vectors, isn't it? So the third vector, you take anything, maybe alpha beta, you are going to say that anything, whatever you are going to take, I can give you the coefficient. If you take 3 9, I will give you the coefficient which are 3 9 itself, right? And that's why I'm calling these two vectors as a convenient vectors, because the giving me the coefficient is very easy to me. This is 1 0 and this is 9, which is 0 1. So if I have these two vectors in my set, you put any third vector and I can give you the coefficient. But is these two vectors are the only vectors that can do this magic, or there are other vectors also? Actually, any two linearly independent and R2 will do that magic. So let me just build the basic. These two vectors I'm just calling a special vector, or let me just call it convenient vectors. Okay, so let's suppose these two vectors are some vectors, but these two vectors are not the only vectors that can do this magic, which means you take any two linearly independent vectors. Let's suppose these are the two linearly independent vectors. How to check? For 2 it is extremely easy. Actually for 3 it is tough, to be honest, and that you have to do it using the rank. Okay, I will come to the rank. Then you will get to know that how to systematically check whether the set of vectors are linearly dependent or independent. But for 2 it is actually very easy. You just check whether one of them is coefficient of another. So 3 into 2 6 you are getting, but here it is mismatching, so that's why these two are linearly independent, right? These two are linearly independent. You give me any third vector, I will give you the coefficient. Let's just see how. See, this was 2 3, this was 5 6, right? Now you give me any third vector. What you just gave me, let's suppose you gave me 4 9. Now I will say that okay, I can represent this 4 9 as a linear combination of other vectors, which is 2 3 and 5 7. And what are the coefficient? 5 6. What are the coefficient? There must be some coefficient here. Okay, I'm not going to calculate it, but there must be some coefficient. So basically, if you have two linearly independent vectors here, okay, in R2, if you have two linearly independent vectors, then whatever the third vector you have, you can definitely represent the third vector as a linear combination of these two vectors. If you have, instead of this 2 3 and 5 6, if you have, let's suppose, some convenient vectors to me, which I'm calling and 1 0 and 0 1, right? I'm calling, let's suppose, 1 0 and 0 1 as a convenient vectors. Then then you can immediately give me the coefficient, right? Finding the coefficient is very easy to me. That's why I'm just calling them as convenient vector. Otherwise, there is nothing special about these two vectors. Okay. See, these two vectors, which is 2, 3 and 5, 7, are linearly independent vectors. 1, 0 and 0, 1 are also linearly independent. Why? Because you cannot get this as a linear combination of this vector. If you multiply by the 0, then from this one you will be getting 0, but from this 0 you cannot get 1, right? So that's why you cannot get one from another. That's why these are the two linearly independent vectors. This is also two linear independent vectors. These are also two linearly independent vectors. These are also two linearly independent vectors. It is just that these two linear independent are just convenient to me, because whatever third vector you give to me, I can immediately find the coefficient, which are 4 and 9, right? But here the finding the coefficient will take some of the time to me. Is this clear to everyone? So what I'm saying, you take any two linearly independent vector. Okay, if you're taking convenient vector, I'm very happy, to be honest. But if you're not taking convenient vector, you're just taking two linearly independent vector in R2, then you take any third vector, you can represent that vector as a linear combination of these vectors. So basically, this is called filling the space. Okay, filling the space. This is the last concept or the last intuition that we need to know, and then we can directly jump to the gate problems, which means till now I was just building some intuition, some basic definition I have to tell, that what is linearly dependent, what is independent. Till now I have not told you anything, and then we are going to see some magical thing, to be honest, that how to multiply a matrix and a vector. You might think that you know, but you will get to know, okay, that I mean how well we can understand ax, I mean multiplying a matrix and a vector. But before that, I just need to fill one more conceptual gap, which is filling the space. So what do I mean by that? What is space? You do not actually need to know. It is just an intuitive, in the intuitive sense, I'm just telling you, right? Okay, which means there is no technical term which is filling the space or something. Technically it is called span. Technically it is called span, but since I am going just with the intuition, and you do not need to know technical terms for now, that's why I'm not telling you the technical terms. Only intuitively I'm telling. Technically actually it is called span, but you do not need to know this, right? Anyway, let's just see that what is this filling the space. What is the space? Technically you do not need to know. I will tell you the intuitively. Basically, let's talk about the R2, which is x and y. Now, this thing is called space. Space means any vector that you can generate, which is called basically space. The set of all vectors is actually space. I mean, every vector in R2, basically R2 is a space, you can say. Okay, R2 is a space. You can say R2 is a space. Definitely it is a space. So, if I want to fill this space, what do I mean by that? You take two vectors, okay? For example, I'm just taking convenient vector for now, which is 1, 0 and 0, 1. These are just convenient vector to me. You give me any vector. 2, 3 you want to give me, I can represent 2, 3 as a linear combination of 1, 0 and 0, 1. How? 2 into 1, 0 plus 3 into 0, 1 equal to 2, 3. You give me any vector, I can represent that vector as a linear combination of these two vectors. Definitely I can do it. So that's why I'm saying that these are just convenient vector, but it does not mean that these are the only two vectors which can fill the space. There are many, or there are infinitely many set of two vectors which can fill the space. You just have to take two linearly independent vectors. Okay, so the moment you are taking two linearly independent vectors, so just take two linearly independent vectors. You do not need to take this 1, 0 and 0, 1. This 1, 0 and 0, 1 are just convenient vectors. That's why I was just taking. But you just take two linearly independent vectors. Maybe anything of your choice. Okay, so let's take two linearly independent vectors. One is, let's suppose, 1, 2. Okay, another one is anything, maybe 2, 5. Since these are two linearly independent vectors, I have picked these two linearly independent vectors. Give me any vector, whatever you can think of. Give me any vector. I can represent that vector as a linear combination of these two vectors. Okay, you give me, let's suppose, anything. You give me, let's suppose 3 and this is 7, but okay, let's suppose you are giving me 3 and 6. Okay, or 3 or 5 or whatever, right? You may think that you cannot represent, but I will show you that you can represent. How? You just write this 3, 5 as a linear combination of these two vectors. 2, 5, maybe this is C1 plus C2 into 1, 2. And currently I am not solving. Trust me, you can easily solve this for the C1 and C2. There will be two equations, C1, C2 will be the valid answer. Okay. So basically earlier this 0, 1 and 1, 0 was very convenient to me, because you give me any vector, I can give you the coefficient. Here also I have taken two linearly independent vectors that also fill the space. 0, 1 and 1, 0 also filling the space. Filling the space means that linear combination of these vectors are giving you the R2. right? The linear combination, the set of linear combinations like 0 1 and 1 0. If you take all the linear combination of 0 1 and 1 0, it will fill whole of the space R2, which means you pick any vector from this R2. This 0 1 and 1 0 will that vector is a linear combination of 0 and 1 0. And not just 0 and 1 0, these are just two linearly independent vectors which are just convenient to me. Okay, as a human, that makes my calculation easy. That's all it is, just making my calculation easy. You just take two linearly independent vectors, whatever it is, 2 5 1 2. These are also filling the space. Okay, you give me any vector which is 3 5, I will tell you C1 and C2 which are actually true here. So you can solve this equation. I'm not going to solve it, but if you want to, it will take just hardly 1 minute. Has anyone solved it? Let me know C1 and C2 if you have solved it. Okay. So have you understood this? What I'm saying? What I'm saying here is that it is important to understand that two linearly independent vectors can fill the whole space of R2, which means you give me any vector, okay, in the R2, I can represent that vector using those two linear combination, those linear combination of those two linearly independent vectors. So any two linearly independent vectors in R2 fill the space. Filling the space means that they can create, filling the space means they can create any other vector. They can create any other vector that you can think of. This 1 0 and 0 1 are just convenient vectors to me. That's all. It's not like that these are the only linear independent vectors. These are the two linear independent, and these are just convenient. As a human, these are the convenient. That's all. Okay. Now suppose I give you these three vectors. Anything 1 2, maybe 3 3 4, anything, maybe 4 5. Now tell me, are these three vectors linearly independent or dependent? So what you will do, you will say that in R2, so there are two concepts. One is that in R2, if two vectors are linearly independent, then they can fill the space. Okay. So here, if you put if you pick three vectors, okay, then it means what? These three vectors cannot be linearly independent. I mean, this set cannot be linearly independent. I will tell you why. So this set cannot be linearly independent. I will tell you why. Don't worry. So basically, I'm going to tell you. So this is the last concept again that we are going to study. Once you understand that, okay, what is filling the space and this, then I just want to convey very less thing which are important to you. So I will just convey this, and then we will be moving to X equal to. So is it wise to take 10 minutes of break before I continue? Is it wise to take 10 minutes of break? And then I will tell you very interesting thing, that how to multiply a matrix and a vector. Those who have studied, they might already know. Those who have not studied, then they will get to know very magical thing, that how to multiply a matrix and vector, and all of the whole story that we have told you are going to connect in Ax equal to b. And in every IIT and ISC, they are just going to ask you the connection between Ax equal to b and the linearly independent and independent sets. Ax equal to b, and then whatever we have just studied, linearly independent and dependent. So basically, they are just going to ask you relation between these two. That's all. So in interviews. Now after the break, we are going to cover this gap. What is this? Okay, this gap we are going to cover, or not gap, I will say the connection. This is not the gap. Actually, both are the same thing. You just need to relate it. After break. Cool. So let's do one thing. Let's just start at maybe after 15 to 20 minutes. So I will schedule a class maybe 4:20 or 4:25. Okay, maybe 4:25. So let's meet after half an hour, so that I can actually I have not also had a lunch, so you can also take some break, and then we will meet at 4:25. Cool. Let me know if there is any doubt.